meet this week via Zoom. So starting next week on Wednesday, we will be back to school, back in the same classroom, BHCC 106 or 108, the same classroom that we meet. So next Wednesday, so Monday is still Zoom, and then Wednesday will be in campus. Right now we are doing that. So I will send you guys an email to remind you guys that on starting next week, we'll go back to our normal schedule. I do receive some questions about your homework when you find the margin of error. Okay, so thank you for reminding me. So you go to the StatCrunch, and then you will go to the stats, proportion stats, one sample with summary, and they will ask you for how many number of success. So based on this, X is the number of success we have, so it's 198. Number of observation is 4614, and the confidence level we're looking for is 95%. So this is they provide in the question and you compute. So the lower and the upper in this case is this number, 0.0 something. So the lower in this case will be 0.0371. Usually I go for 4 decimals place. The more you round, the better your answer, the less error you get, 488. So this is your lower and your upper in this case. So what we do here is we just subtract this 2 and divide it by 2. So you just take 0.0488, subtract the upper, subtract by the lower, 0.371, and then you divide this by 2. So so this is how you find the margin of error the quickest ways. So this is going to be 0.00585. And that is the way. Otherwise, you're going to do the long. I do not recommend you to do the long way. So that's why I want you to do this way. So in 3 decimal place is 0.006. And then they will ask you for the confidence interval. So that means you already did this. So I just tell the students that you actually do C first, then you do B. So some of you ask me to say, yes, in this case, you do part C first and then part B. So the confidence interval is these 2 numbers. So in 3 decimal place with 0.037. And the other one is 0.049. So that is then they're asking for how do we interpret. So it's a 95% confidence that the interval, so it's going to be part C. C will be your answer. So we don't use the word chance. We don't use the word sample. So make sure you guys don't pick the one with the chance or the sample. That will be your answer in this case. So some students ask me about this. So the part B first. Yes, you actually do part C first, then you do part B. So actually C comes first in this case. Anyone have any questions for me with this one? 7.2, we'll hold on to it first. Another announcement is your homework due tonight is only 7.1. Let me repeat. The only homework due tonight is 7.1. So 7.2 and 8.1 is due next Wednesday. So with only 7.1 is due this tonight. Okay, just to clarify it.
Hello,
yes,
hello,
question.
Prof.
Yes.
But I already did mine 7.2. Is that okay?
Yeah, if you did it, it's good. Then that means you only got 1 homework due next week.
Oh, okay, thank you.
I haven't finished 7.2 yet, so that's why today we go over 7.2. Anyone have any questions for me on 7.1? All right. So if you have questions, just stay back after class. Then I can help you with it. Next, we'll continue with 7.2. So we did not do any examples on 7.2. So we'll go through some examples in this case. So the first example in 7.2 is asking us to construct, find the critical value. Is that Z alpha, T alpha, or neither? And then using a 95% confidence level in this case. So before I continue in this case, you need to know what is the alpha in this case. So if I ask you for a 95% confidence level, what is your alpha in this case?
0.05.
Yep, that would be correct. 0.05, which is 5%, opposite of 95. Now, in order for you to find critical value, there are two ways to find it. Either you use Z alpha or T alpha. So if you're using Z alpha, you have to use your calc. If you're using Z alpha, you're using normal calculator. Okay, this is for Z alpha. So if you're using Z alpha over 2, we are using your normal calculator to find out. But if you're using T alpha over 2, you will be using also calculator, but we're gonna use T calculator. So in your StatCrunch, there is a normal. When you go to calculator, we got binomial, we got normal that we use in chapter 6. We got T. So how do we know that we are using Z alpha, T alpha, or neither here? So please pay attention. This is very important. Okay. You will only use neither when your when your population is skewed, or in this case, not normal, and your sample size N is small, which in this case is less than 30. Okay, so the word N in this case means that it means you have to fulfill these two conditions. So when you read it, you say it's if your population is skewed, or in other words, not normal, and if your sample size is small, then it is neither. In order for you to use Z alpha over 2, this is where sigma, looks like a number 6, is the symbol looks like is known. Okay. And if you're using T alpha over 2, this is where sigma is not known. So usually we'll check for this condition first. If the population is skewed and the sample size is small, if that condition fulfilled, then it is neither. Otherwise, then it is Z or T, depends on your sigma. If sigma is known, we use Z. Sigma is not known, we use T. So I want you guys to read question A. Can you tell me, is this a Z alpha, T alpha, or neither? Read question A and
T alpha,
why is T alpha?
because it is unknown.
Yep, sigma is not known. And the population is normally distributed, so it's not neither. So that is correct. So this is T alpha. So in order for a T alpha over 2, I'm going to use A in this case because I'm laser type alpha here. It's not A, but I just use that just to simplify. How do we do this T alpha? Is you use your normal calculate, your T calculator. So what you do is you go to your StatCrunch. Okay, you go to stats, calculators, T. That's one called T calculators. Your degree of freedom is the one that they want you to type in. How do you find the degree of freedom? So the formula to find the degree of freedom is N-1. So if a question wants you to find what is the degree of freedom for T. Your degree of freedom formula is n minus 1. So if you look at this, what is our n here? N in this case is 9. So 9 minus 1 is 8. So your degree of freedom is 8. Okay. And you want a 95% confidence interval. So you change it to become greater than. And then you take 0.05 divided by 2. Okay. So this is how you find your T alpha over 2 using your T calculators. The degree of freedom formula is n minus 1. You use greater equals to, and then you hit compute. This number is your T alpha over 2 in this case. Okay, so make sure you put. How do you put this in? Usually this is asked in your I'm gonna write in here so it's easy for me to. So this is question. This is 7. Sorry, 7.2. Question 1A. So we are using T alpha over 2. So your degree of freedom in this case is 8, because it's 9 minus 1. Okay, and then you put Px. This is T calculator in your StatCrunch. Greater than or equals to blank, and this is 0.05 over 2. This is the same thing as alpha divided by 2 here. So your answer in this case is, what's my answer here? Wait, there you go. 2.306. So this is my answer. 2.306. You guys okay?
I have a question.
Mm-hmm.
So 7.1 for the confidence level, let's say if it's 95%, we're always going to put 0.95, but with 7.2, we're going to do the opposite. So if it's 95%, we're
this is finding no. This is finding critical value. Okay, so we are finding for critical value here. We are not finding the confidence interval. Okay, so if a question is finding critical value, we are using this. If a question is finding confidence interval, then you use 0.95.
Okay.
Mm-hmm. So you have to watch out what the question is asking you for. So if a question is asking for critical value, we use the 0.05. If a question is asking for confidence interval, we use the 95 in this case. You got what I'm trying to say?
Yep.
Okay. Again, read the question carefully, and like this is finding the critical value. This is to find the confidence interval. So it's very clear. It's not something that so the answer here is 2.306. Okay. Next, we're gonna read question B here. So it says that n is 5, the sample mean is 20, sigma is known, and the population is very skewed. So is this a neither, a Z, or a T? Anyone?
The Z,
Why you say it's Z?
because sigma is known.
Okay. But do not forget that, do you check the neither condition? Make sure you check,
Okay.
as I said, you have to check this one first before you go on, right? Do you check this condition first?
Well, it is neither because it's less than 30.
And also what the
And
population is?
It's less
skewed.
than 30 and it's skewed.
Yep. So do we care about the sigma in this case?
No.
No. So this answer is neither. Okay. And the reason why is because the sample size is small, which is less than 30, and the population is skewed. So that's why it's neither. You do not need to find what is the value is, because this one is no good. Okay. So the first one is T alpha over 2, and the critical value is 2.306. Again, we're looking for critical value. Now read the third one, part C. What do you think about part C? Is that neither Z or T?
I think it's Z.
Why is Z?
Because, well, because the sigma is known and it says the population has a normal distribution.
And so once you say population is normal, do we need to worry about the sample size?
No, I don't think so.
Nope. Yep, because it is an and means that if one of them is no good, the whole. So this is correct. This is a Z alpha over 2 here. The reason why is because it's not neither, it's because the population is normal and sigma is known here. So in order for us to find the Z alpha over 2, you have to use the normal calculator. So you go to your stats calculator and normal, it's hiding. The mean is 0, the standard deviation is 1. And same thing, we're gonna make it greater than, and then your alpha is 0.5 over 2. Okay, so this is very similar to the one that we did for the T. We just make the mean as 0 and 1, greater equals to blank, and then alpha over 2, which is 0.05 over 2. That will be 1.96. So in this case, this is what I will want you guys to write. So 1B in this case is neither. The reason why is because your population is skewed. And your sample size is very small, in this case 5. So that's why it's neither. For part C, this is Z alpha over 2. The reason why is because it is sigma is known here. So you have to use the normal calculator in your StatCrunch. Your mean will be 0. Your standard deviation will be 1. And you do the same thing, px greater than or equals to blank. And you use 0.05 divided by 2. So this answer will be 1.96. Okay. So this answer will be 1.96. All right, read the last one, part D, and figure out are they neither Z or T in this case. I think you have these notes, right? Part D. Anyone? Is that neither T or Z?
This one's a little confusing. Wouldn't it be neither because it's
I
unknown
think-
and it's
I
a
think
skewed
it's T.
distribution?
Okay, so Casey say neither, Lawrence?
Yeah, I think it's T alpha.
T.
Yes, T alpha
Okay.
over 2.
Don't forget that for neither, its population is skewed, but what happens to your sample size?
The sample size is more than 30.
The sample size is large, it's more than 30. So in this case, it's not neither here because your sample size is greater than 30. So it's not smaller than 30. So that means neither is out. And sigma is not known. So that means that this is going to be a T alpha over 2 in this case.
Okay. So how do you know like which one you're supposed to look like, which one you're supposed to follow? Because it says it's unknown
Mhm.
and it's skewed, but it does say n is greater than 30. While like C, or not, what's the other one? B, where it's known, but it's skewed.
Okay, the
Like, how do
known and
you can
okay.
choose?
First thing we always look for is the neither case.
Oh,
It has to
okay.
fulfill both of these first. And if you fulfill this both, then it's neither. But if one of these does not fulfill, that means it's either Z or T.
Oh, so
And
it's
you
only,
look,
okay, it's one, okay.
and you look for sigma is known or not. So you always check for the neither one first. So for this case, the neither one does not work because your sample size is great. And sigma is not, then we can move on to the next one. And now since sigma is not known, so it's going to be T in this case. So using your T calculators, because we're going to use T calculators in this case. Calculators T. What is your degree of freedom here?
74.
So it's 1 less than the sample size, 74. And we still use greater. We use blank. And then this is 0.05 divided by 2. Because our alpha is 5%. And you hit compute. So this is going to be 1.992. So the critical value in this case is 1.992. So make sure you do, as I mentioned early on, find the neither one first. Check the neither condition first. That is what I want to say. Check the neither condition first, and then after that, check the sigma is known or sigma is not for the T or Z. So for 1D, since neither is no good, so you can cross the neither off. The reason why is because your n is greater than 30. Okay, so since sigma is not known, so so in this case we will use a T alpha over 2. So
the degree of freedom, is that only used when it comes to the T calculator?
Yes, yes.
Okay.
Yep. And T only find degree of freedom. In this case will be 74. And then you take Px greater than or equals to blank. And this is equals to 0.05 over 2. And this is your answer, which is 1.992. Questions? Okay. Yes, if you're using T, you're using a StatCrunch, they will ask for your degree of freedom. If they ask, if you use Z, they will ask for the mean and the standard deviation, which in this case will be always 0 and 1. Okay, so that's the only difference between the T and the Z in the StatCrunch. Anyone have any questions here? Next, we're going to talk about here is doing, now this is fine, as I said earlier on, right? This is finding the critical value. So read the question carefully. So if the question asks you to find critical value, make sure you use the 9.5%, which is the opposite of 95%. Like if you look at question 2 is where you have to find the confidence interval. So when they want you to find the confidence interval, then you will use 0.95 here. Okay, so make sure you guys know the difference between majority of your question is going to be finding confidence interval. I think there's only like 1 or 2 questions in your test that ask you to find critical value. So majority is confidence interval. This is where you have to refer to your data called CHIPS OK. I think in your, so how do you find this in your data is you go under your StatCrunch in your elementary stats stat way. Go to the data stats, and there should be one is talking about cookies. Let me see. I think it's named. I think it should be over here somewhere. Where was that? Chocolate chip cookies. There you go. Okay. So it will be chocolate chip cookies. So so if you click on this, the data will be here. So what is this data is, as you guys know that there's a lot of different brands of chocolate chip cookies. One of them is called Chips Ahoy. There are a few of these Chips Ahoy, but if you click on it, they will tell you that these are different type. I think one is a regular, one is a sugar-free or something like that. And then one is different types, maybe another, there are 3 different types of Chips Ahoy, Keebler and Hannaford. So there are 5 different cookies. And what did the author do is he will take that cookie, let's say Chips Ahoy, you open up the Chips Ahoy, you take out the cookie, and he crumble the cookies and count how many chocolate chip inside that cookie. So he counted it. So the first cookie, he take it out and crumble and found there are 22 chocolate chips inside this Chips Ahoy cookie. And then he take another new cookie and crumble it and repeat this. And this is what he recorded. And then he do the same thing for the next brand. I think this is sugar-free. And then the next one. And then after that, he will buy the Keebler, which is another company that produce chocolate chip cookies. And he will crumble it. And then Hannaford, another one. Okay, so there are 5 different. So this question, if you look at question number 2 here, is where you refer to Chips OK, which in this case is the chocolate chip cookies. You need to find a 95% confidence interval for the mean of this. So how do you find a 95% confidence interval for this? It's very easy. You go to T-stats. You go to calculator first. Stats first. Let me see. Yep, stats and then T-stats. So you go to stats. Sorry, stats. T-stats. You're gonna pick with data. The reason why this is with data is because the data is all in not this one. It's imported into your formula. So we're gonna do the one with the data one. So what we do here is, what is this follow? So you go under stats, T-stats, one sample with data. They want it to be, so now we can see that one is chewy, one is regular, one is reduced fat. They want just the regular one. So regular is this fellow. And you're looking for a 95% confidence interval, so 0.95. So don't use 0.05 here. Again, don't get these two mixed up. And you hit compute. So for the Chips Ahoy one, the 95% is this. And if you want to select more, because the question also wants us to do Keebler, right? The question wants us to do both of them. One is a Chips Ahoy and one is a Keebler one. So actually you can select both of this. So what you do is you go to Chips Ahoy and then you hold on to your control key in your keyboard and then click on Keebler. So now you've got 2 of them. One is Chips Ahoy and one is Keebler, and you hit compute. So what you do here is you do two confidence intervals for each one of this. So this is the confidence interval for both of them. So for the Chips Ahoy regular, the 95% confidence interval is given us by 23.13 to 24.77, and the units in this case is chocolate chips. So that means that if you go buy a Chips Ahoy cookie, a regular cookies right now, and if you crumble that cookies and find out how many chocolate chips, it's going to be around 23, 24, or 25 chocolate chips in there. Okay, that's what it means. Okay, so this is for population, means everyone. So if you go out and do it now, this is how many cookies, chocolate chips you find in this case. For the Keebler one, which is another brand, 95% confidence in this case is given us by 29.2 and 31.6. 29.21, sorry, just 21 and 31.62 chocolate chips. So this is how you find if you have data and you import it to your StatCrunch, and you will do t-stats with data. The question wants us to compare these two results. So if you compare these two, the Keebler and the Chips Ahoy, can you tell me which company have more chocolate chips in their cookies? The Chips Ahoy one or the Keebler one? And why you say that? Which one has more chocolate
It'd be
chips?
Keebler
Why, Armin?
because the intervals are higher and like it's kind of self-explanatory.
That is good. Well, do not say it is self-explanatory in your test, because you won't get full points.
Yeah,
I mean, I know what you mean. That is
but
correct.
is this where we do the we're confident that it's the true values in the interval?
Nope. That is if you want to do that, that is the interpretation.
Oh, okay.
So if they want you to interpret, then you do VR 95% confident that that is interpretation. This question did not ask us for interpretation.
Okay.
This question asks to compare. So you just pick which one is it, and as you say, is correct. So Cleaver has more chocolate chip. Chocolate. I cannot spell today. Chips in. Not chips, chips in their cookies, because the confidence interval is greater than the Cleaver one, than the Chips Ahoy. So if you are a fan of chocolate chips in your cookies, if you like a lot of chocolate chips inside there, then you go for the Cleaver company. Questions? Anyone? Okay. One mistake as what Casey brought up, do not use 0.05, then you only find the 5% confidence. So this is what happens. See, if you look at this class, I want you to know that. See, when you look at this is a 95%, which is the match of this. So what happens if you put 0.05 in this case? You're not calculating the 95%, you're calculating what? The 5%. So that's the difference of what I want you to do. I want you to find the 95, not the 5%. So I just want to point out to you guys so that when you guys got an answer, do not simply just copy. Oh, David says this too. Just read through it. Make sure this is 95. Okay. So that you match this. So a lot of students just blindly just put your answer here. Okay. So in this case, we can make a conclusion that Keebler is better than Chips Ahoy if you're talking about chocolate chips. So my question is, what happens if the intervals are overlapping? Okay, so what happens if the example I give you here is the Chips Ahoy one, the confidence interval is this 23.13 and 24.77. And what happens if I found the Keebler one? Keebler one, let's say, is not this, because I changed it to, let's say it's 24.2 and 25.6. Example. Okay, not this, but something like this. This is what you get for your Keebler. So my question is, can you still say that Keebler, if you compare this, can you still tell Keebler has more chocolate chips in their cookies compared to Chips Ahoy? Can you say that conclusion like what we did over here? What do you think? Yes or no?
I think yes.
Okay, so Lawrence say yes. I know this is bigger, right? 24.2 and 24. This is you know. So can you still say this company has more chocolate chips than this? To answer this question, the answer is no. You cannot say that.
Is there like a
Why did you say that?
percentage?
No percentages. So this is the note that you need to know. This is very important note. If the confidence interval overlap, do they overlap here?
Yes.
They
do.
overlap. Okay. So if the confidence interval overlap, then the conclusion, then you have to say they are the same. They are equal.
Okay. Yeah.
Wait.
Professor Dave.
Wait for a minute.
You know,
So if the confidence interval overlap, means they are equal, means that they are the same.
So if the Chips Ahoy is 24.72 and then the Keebler is like 24.73, then
And
that's not overlapping?
That is not overlap.
Oh, okay.
Overlap
I thought
means
yeah. Well, I thought maybe, you know how like in the other ones what we've done where there's like a 5%, you know, like
we don't do
difference.
that
and
yet.
then
Nope, this
Okay.
is a recalculate the 5% everything.
Okay. All right.
So
thank-
if they overlap like this, means one overlapping, I don't care how they overlap, a little more like this, then these two are treated as the same. That means these two, company A and company B, is the same or equal. Okay, but if you find out that your company A is this and company B is this, then we can say B is better than A. Okay, which is okay. And the same thing happens if your A is this and your B is not overlapping, they're not overlapping, then in this case, A is better than B. Okay, so I can change this to become A is less than B because it's the same thing. Okay.
So
This one is
Professor
A
Dave,
equals to B. Yes.
so it's a rule that when they are overlapping, then they are equal.
Yes, if they're overlapping,
doesn't-
they are equal.
So it doesn't matter if the upper limit is higher than the other one.
Doesn't
if they
matter.
overlap.
When I say
Okay.
overlap means something like this.
Okay. Yeah, because I came across questions like that in 7.2. Yeah,
Mhm.
and I was having yeah. I get it.
Yep. Now I have to teach you now. So yeah, now you know what's going on. So you need, this is very important. So when you want to compare two things or two A and B or Chips Ahoy and Keebler, whatever you're comparing, if they are overlapping, this is called overlapping because they overlap here, then they are the same, or in other words, A and B is equal. Okay. If A and B is like this separated, B is not, they're not overlap, but B is higher than that. So in this case, A is less than B. The other way around, A is greater than B. And again, this cannot, no overlapping involved in this case. Okay. So, but for our example here, because they don't overlap and we find out that your Chips Ahoy, this is your Chips Ahoy, and this is your Keebler, they are, Keebler is a bit far away from Chips Ahoy from the confidence interval. So this is your, this is what happens. That Keebler is better than Chips Ahoy in this case. Questions, you guys? Yeah, you will see this in your homework. You're correct, 7.2. So this is very important. Okay. So the next example is a little bit different from example number 2, is because example number 2 came from data. If you read question 3 is where a random sample of birth of 186 babies with a mean of 3103, standard deviation of 696. These are the babies who mothers born do not use any substance during their pregnancies. So this is special is because this question did not provide you 160 babies data. They just did the work. Oh, what is 160 babies? They found out the mean is this and the standard is that. So when you do this in your StatCrunch, you're gonna do with summary. So you're still gonna go to stat, you're still gonna do t-test, but this time you're gonna pick with summary. Okay, So that is the difference between the data one and the one with the summary. Okay, so they provide you the what we call summary statistic, the mean, the median, the mean, the standard deviation, all those things. But before we go on, so we need to answer part A first. So question A is asking us, what is the best point estimate for the mean height of babies who's born by mothers who did not use substance during the pregnancy? So in this case, they want you to find the best point estimate. So does anyone know what is the best point estimate here?
You mean?
That will be your sample mean. Yes, that is. So do the question provide us the sample mean?
No, we have to
Without-
figure it out, don't we?
Hmm?
Don't we have to figure, I mean, they gave us the numbers, but don't we have to like still plug it in to figure it out?
No, the mean is this.
Um,
3,103 grams. You do not need to do
Oh, I
anything.
see it. Sorry.
This is the mean here. So if they provide you, you do not need to do any work on it. Mhm. But if I give you this, if I give you this chocolate chip, if I want you to find what is the chocolate chip, what's the mean chocolate chip for Chips Ahoy, then I do need to go to your data here, and I need to find the mean, which is summary stats. Remember that you did it in your midterm. And then you want to do Chips Ahoy, and the mean in this case is around 24. So this is how you find the mean. If they give you the data, you have to literally go to the summary statistic that you learned in chapter 3. But if they provide you the summary statistic, you just use it.
Yeah, Professor Dave, yeah, I came across some of that, so I had to go to like the stats calculator, then column.
How to?
I mean, for 7.2.
Yeah, you go to stats, summary stats, column.
Yeah, exactly. That's what I was doing.
Then you pick Chips Ahoy. This is how you find a mean. Remember, you do that in your test,
Yeah.
your midterm.
Yeah. That's what I did for 7.2.
But you are not but this question is looking for confidence interval, not looking for mean.
Yeah, but there are questions where you have to go find the mean first. In some of the
That is
questions,
how you find the
7.2.
mean. Yes.
Yeah.
Yes, that's how you find your mean. If a question gives you the data.
Yeah, thank you.
So depends on the questions. That's why you have to read the questions and see what they want.
I have another question. So in your packet that you emailed me, for 7.2, in the homework, it says SX is the sample standard deviation, correct?
Yes.
Okay. I just want to confirm that because in the stuff that you emailed us, it just says X. Oh no, I'm sorry, it just says S. So I wasn't
S
sure.
and XX is the same. Yeah.
Okay.
Yep.
But
S
well,
and SX like this, they are the same. That's standard deviation.
okay, so when we do the test or
Doesn't matter.
it's
Doesn't matter.
well, I think it matters because I want to know what it's going to come up as, so that because I'm sorry, I'm getting confused because I'm so used to it saying SD for standard deviation, and now we're
Then use
switching
SD.
to like SX.
Oh, the reason why
know,
the reason why I rather use S in this case is because
Yeah.
This is why I'll point out, because when you go to your StatCrunch, when you go to your stats t-test with one sample with summary, with summary, then I'm not very picky. You can use SD in this case. Pick the symbol that you use.
No, that's not what I mean. I mean, like when you actually when you're in the homework and it shows you, it gives you a list. It doesn't say S, it says SD. Or I'm sorry, SX. That's why I wasn't.
XX, S, SD, all the same.
Okay.
Potato.
Well, I just wanted to make sure because when I started doing 7.2, I honestly couldn't figure out where the standard deviation was.
They're all the same. S, SX, SD, they're all the same.
Can you go back to the StatCrunch? I have another question about that.
Mhm.
So when you plug this in, do we never go to where it says perform, right? We always check where it says confidence interval.
Mhm.
Okay, and then for
Then you type
that,
in.
yeah, but we're always doing the confidence interval, right? We're not doing the where it says perform. And then where before, if you hit perform,
So because we are finding confidence interval here, we are doing confidence. So all chapter 7, we are doing confidence interval.
okay.
And then when you do chapter 8, we will performing a hypothesis testing.
Okay.
So again, read the question carefully because the question is asking for confidence interval. We are doing confidence interval.
Okay.
And then
Thank you.
when chapter 8 comes, we'll do the hypothesis. We just pick the top.
So one of the questions that she was doing, he didn't give her the point, the confidential interval or confidence interval. So when the question doesn't give you that, do you just stick to 0.95?
Do you know what question you're talking about? Let me finish
Yeah.
this question.
Okay.
Then we'll talk about that question that you have.
Okay.
Because I'm halfway going through right now. So the sample mean in this case will be 3103. The sample standard deviation is 696. So make sure Suli, can you tell me what question you're talking about on that one? The weight is 180. The sample size is 186. And we are looking for the 95% confidence interval. So you just hit compute. And the 95% confidence interval is given us by this number. So the 95% confidence interval in this case is 3002.3 and 3203.68, and the units here is all in grams. So this is how we find a 95% confidence interval for this mean birth weight. Now, some questions when you do your online homework on 7.2, they give you the whole confidence interval, like 7.2 question 1 that so this is 7.2 question 1. So this is already given to you. This is your confidence interval. So you do not need to find it. So your confidence interval in this case will be 13.05 in 2 decimal places and 22.15. So some questions provide you the result of this. So they provide you the result of the StatCrunch. Remember, you got a StatCrunch, you got a result. So they provide you this result. So they provide you this result. So you do not need to do any StatCrunch work on this. You guys with me? Does anyone know how to find the best point estimate here?
Yep.
What is the best point estimate in this case?
That's gonna be like 17.5.
Yep, the X bar.
Yeah. Yeah.
So it's going to be 17.6 here. Okay. So if a question provide you this, you use this. You do not need to do any StatCrunch, any work in this case. Do you guys know how to find a margin of error here?
Yep.
How, Lawrence?
22.15 minus 13.05 divided by 2.
Yep. So subtract these two and divide by 2. That is how you find your margin of error. So you do not need to use, again, if this is a result from the StatCrunch, so you do not need to do any work. It's been done for you. You just need to know how to read this result. Okay. Is that what you're asking for, Casey and Suli?
Yeah, because I didn't realize that that
Same
was,
thing in,
yeah.
yep, same thing in question 2. You use this same thing.
Yeah,
So do not just watch. This is the one that they use. So if they provide you same thing, question 3, use this. Because they already give you the confidence. This is your confidence interval, the one that is on the first line here.
yeah, I didn't realize that. I plugged everything in, and I mean, I should have realized
No,
that, right?
yep, no need. Yep. But once they give you, once they like this, they don't give, they give you like this type, then you have to plug it in to your StackCrunch. Because
Okay.
that's not your results here.
But there was one where she was saying that like we didn't know if we were
They all
supposed to hit the
mostly
0.95
have it.
something.
Yeah,
Okay.
I can tell you they all have it. The only time that you don't have it is that they give you the results, like the first few questions, like this one. So they even tell you it's 95%. So yeah,
Oh, you know what? I get it. No, it's because when I plugged it in, it does come up as the 0.95. But like you said, if I had been paying attention and I knew that it was right here, then I wouldn't have to plug it in and I wouldn't have to worry about the 95%.
mhm.
Okay, that makes sense.
And as usual, it's always going to be 95% if they don't give it to you.
Okay,
I
all right.
can
thank you.
tell you that. Yeah, if I don't even give you this number, if I want
Yeah.
you to find it, if I don't provide what is the level, it's always 95.
It populates in there already, right? I
Yeah,
think it
it's
does.
most, yeah,
Okay.
that is the common level we use is 95.
Okay, that makes sense. All right, thank you.
Yep. Question C is asked us to write a statement to interpret. So when I want you to interpret in C, means you have to use the word VR95, this one. Okay, so I want you guys to go ahead. Part 3C here, I want you to write a statement to interpret this 95% confidence interval, which is very similar to VR 95%. Very similar to which one? Which is the correct way to interpret this confidence interval? If you look at your homework here.
C is the correct way.
Which one?
C.
C, yeah, C is the correct one. So I want you guys to write it out because in your test, it's not a multiple choice like this. It's not A, B, C, D like this. It's going to be like the one that you did over here. You have to type, you have to write, not type, write it out. So VR or VHAF, doesn't matter, 95% confident that the interval from, what's the interval we get for part B? 3,002.3 grams. I just make the number a bit shorter. And 3,203.7 grams are contained. So you just continue. The true value of the mean I will use the word population mean of the population mean instead of mean of the population. And then you just copy and paste what is this talking about. This is talking about birth weights of weight of babies born to mothers who do not use substance. So you just copy and paste that. So it'll be the population mean weight of babies born to mothers who did not use substance during their pregnancy. So this is how we interpret this. It's a long interpretation. Again, the keywords: confident, true value, population, mean. Some big keywords here. So make sure you guys know how to interpret this confidence interval. And I would strongly suggest you, because you're allowed to use one paper, right? The finals, you can write everything on a one piece of paper, just front page, not the front and back. Just type that, just make sure you write that in. That is how we interpret confidence interval. D, now you're gonna compare like what we did last time. So this is for healthy moms, healthy babies. And now we got another confidence interval where this time mothers use substance during pregnancy. So this is for not healthy babies. So compare these two. Do the substance affect the birth weight of babies? Does any changes between those two? If you say yes, then if there is a change in this case, then your answer will be yes. Okay. If there is an overlapping case, then the answer will be no. So my question to you is, are these two overlapping?
No.
So that means that does a substance affect? Yes. Okay. So that means that mothers who use substance during pregnancies does affect the birth weight, right? This is common sense also, right? You do look at your data, you know that people who have substance, your mom, if the mother use substance during pregnancy, it's gonna be not healthy babies. So yes, in this case, substance does affect the birth weight of a baby. Because now we can the confidence interval is lower than the healthy ones, which is found in part B. Okay. So in this case, you just compare this and you find out that this actually is way lower than this, means this is why we say that your mother's using substance will affect the birth weight, is because this confidence interval is lower than the one that you found in part B. This is for the healthy ones that do not use any substance. So again, this is something like what we see over here. This is for healthy babies, and this is for not healthy baby. That means that means moms use substance. So you find out that this number is lower than that. So that's why this is considered that is a fact in this case. Okay, which is common sense, which is true. Anyone have any questions on this one? Question number 4. Now I give you data here. Now, if this is an online homework, you just click on the top corner here, and then you just import it to your StatCrunch, right? This is the easiest way for you to do when you guys when you have your online homework, you just import all your data into StatCrunch. However, this one we don't have the import button, so you actually have to type it out into your StatCrunch. Okay. So you actually have to type it out in your StatCrunch. Where is my StatCrunch? Not this one. This is so open a new. Now you have to go to the StatCrunch, the new StatCrunch. Usually, if you do it on your online homework, you import it, but during the test, you cannot import the numbers like these numbers. So you actually have to type it down. So go ahead. Type all these numbers into var1. This is talking about caffeine, so I just put caffeine here just to know that we are talking about caffeine in here. And make sure you put in your data in. And one wrong number is wrong. So these are the 20 numbers data you put in there, and I just double check if the numbers is entered correctly. Again, one wrong number will make you the whole numbers go wrong, the whole answers. All right, we got everything here. That's correct. So this question is telling us that you open up cans of 20 brands of soda, and they have how many caffeine inside this 1 12-ounce can soda. 0 means that it doesn't have any caffeine in that soda. So the question is asking us to find a 99% confidence interval. Okay, so how do you find a 99% confidence interval? Is that with summary or is that with data? Anyone? Is that with summary or is that with data? Anyone?
Data.
Okay, since we got data and enter, so we're gonna do this one. So you go to stats, T-stats, 1 sample with data. So you go to stats, T-stats, 1 sample with data. And the data we have is caffeine. And we do the confidence interval and we are doing a 99%. So it's 0.99 here. And you begin to compute this. So what is the 99% confidence interval here? One.
So it's 19.54 and 45.56.
Yep. Now I know this one doesn't provide you the units. So actually the caffeine is measured in milligrams. I know this in the test usually I'll give you the units as milligram. Okay, so don't worry about the units. So I will provide it to you. So this is how you find a confidence interval. So does the confidence interval give us good information about the populations of all cans? So the question is, do you think this confidence interval is valid or invalid? That's what the question is asking. Valid or invalid? Anyone? What do you think about this? Is that giving good information or not good information?
Is the interval supposed to contain all of the,
Yes.
so it wouldn't be?
Hmm?
So it wouldn't be valid?
So this is not valid. Yes. So the confidence is not valid. Don't forget, every time when you write, when you find a confidence interval, the confidence interval is always go for the population. So the word all that you use here is also mean population. Okay. And the reason why this is invalid, anyone? What's the reason why that this is invalid? Yeah,
Because it
this
doesn't include like 53, 54. Right.
No. We have requirements. Have you checked your requirements on this yet? You guys remember what are the requirements to do this? What's the first requirements when you do this kind of work? So if you look up there, there are requirements. What's the first requirement says? It is
Simple
what?
random sample.
Simple random sample. And the second one is what? Is normally distributed.
Okay.
Or your sample size must be what? Big, right?
Yep.
So my question to you is, if you look at this question, number 4, is this simple random sample? Is this simple random sample?
Yeah.
Do you see the word random here?
Oh, I guess
You're like,
not.
here it has the word random sample, right?
Yeah.
Then
Okay.
we can say, yeah, this is simple random sample, right? But do
Okay.
this have random sample the word?
Wait, so it has to have the word random in there because
No, yes.
if-
You
if-
cannot assume
but if
all
you-
those.
but if you read it, it says obtain in 1 12-ounce can from 20 brands of soda.
Mhm.
So
Is this 20
Isn't
brands
that
are collected randomly?
Well,
So
yeah, because you're taking one from 20 brands.
no, this is
I
all
mean,
20 brands here. They use all
I
20
know,
brands.
but that's what I'm saying. Like you're taking one of each from 20 different brands. It's not like you're taking,
Are they taking
one
it?
from all of Pepsi.
It
I guess
can
this
be.
is throwing me off.
It can be because it's not stated there. It can be Diet Pepsi, Pepsi. I don't know, all these different type of Pepsi you have, right? Pepsi cherry Pepsi. I don't know, all this vanilla Pepsi. I don't know, so many Pepsis you guys have, right?
Okay.
So it can be, but this is something I want to point out to you guys is if the question did not mention random selection or random sample, you cannot assume it. Okay, so no assumption. Do not assume this is SRS if it is not stated in the question. Very important.
So far, everything that we have learned, until to chapter 7.2, it has to be very specific. Like we
The
can't.
7.1 is
assume
same.
anything
It has to be specific. That's why you have the random samples involved.
Okay. All
Now,
right.
what about all this data? Remember the chips, the chocolate chip ones? Now, all this data that is collected from the author, they are all simple random samples. Okay, or every single one of this. So if the data came from this list, it is simple random sample. Okay, it's already in the, if you read in the back of the data set, they will mention that all these data are collected randomly. But this is not stated, so we cannot say that. So the reason why this is invalid is because the data is not SRS. Okay. Now, do not forget also the question wants us to figure out, are they normally distributed? Because your second condition say that it has to be what? Normally distributed, right? So how do we know if this is a normally distributed? We can draw a histogram. So remember the data that you enter here, that you this one. If you click options and add it, you can actually draw a histogram. So you can click on this optional graph. You can do a histogram. You can also do a box plot. You can do so many things here. So I'll do a histogram and let you see. Where's my histogram? Oh, it's on the next page. So this is a histogram. So you think this is normal? Because the question asks, the sample appear to be normal. So in this case, this is not normal. So the sample data is not normal. And the question asks, and since I will have and our sample size is small, right? Which is n is less than 30 here. We've got 20 data here. We have to figure out if there is any outliers. So let's figure out, because we have all these zeros, right? Remember, we got tons of zeros pop up here. So let's figure out outliers. Does anyone remember how you figure out outliers if I give you data like this? You can draw what?
Box plot.
Yep. So you just put box plot in here. And so if you click box plot and compute, and they will provide you box. This is a box plot of ignore the green line. Okay, ignore the green line. This is the box plot. Do we have any outliers in this case?
Yep.
Where?
Oh, no, sorry. I take it back. No,
Okay,
no,
don't forget,
no.
outliers in the box plot is a dot, right? In the far left or far right. So in this case, there is no outlier. So in this case that, so this decimeter is not normal and our sample size is small. So what we do is we have to figure out any outliers. So in this case, using the box plot, there is no outlier. So what is going on is using box plot, there is no outliers in this case. So it fulfill requirement number 2. So what is going on is because if you look at all these examples that we do, we did not went over the requirement check. Okay, as you know that in order for you to do this t-stat, one sample, all these things, you have to go through the requirement check first. If your requirement does not check, your answer that you get here is going to be invalid no matter what. So this is how dangerous. What I want to point out here to you guys is if you just go straight, oh, I need to go through this requirement check, I just go straight down and do the t-stat, one sample, and all these things, and I got my confidence interval. It's not always true. This is something I want to point out to you. It's because you have to go through this requirement check. So the first requirement check is failed in this case is because the question did not mention anything about random sample. That's why this is invalid. The main part is invalid. Our second requirement says that it has to be a normal distribution, and your population has to be big. But if you read carefully the condition here, it says that if you have a small sample size, then make sure you check for what? Outliers. So what we did on this question number 4 here is we have a lots of zeros, and those zeros can be outliers. So we want to figure out if there's any outliers because our sample size is small here. So what do is I draw a box plot and found out that there is no outliers in this case. So actually the requirements that we have for the second requirements, we fulfill it. But unfortunately, we did not fulfill the first requirement. So which is the SRS in this case. Okay. So what I want to point out here as a statistician here is do not simply just go into StatCrunch and put all these numbers and the numbers pop out and, oh, this is my answer, and here you go, this is my answer, right? A lot of things that we did here is we did not check the requirements, and this is question 4 is one of them that that your requirements does not go through. But we didn't check it before we go through it, so that's the reason why that this question 4 is kind of like talking about requirements. So I just want to point out to you guys is when you guys do my homework and they're asking you like, does this interval give us good information? This is actually asking for, do we fulfill the requirements? Okay. We're talking about requirements in this case. Yep. So that is mostly what they were asking for. Okay. That's why I can tell you. This is where I think when you go through the last few questions in your this section 7.2, they will ask you for kind of like this because you didn't check the requirements here. Didn't check it. Anyone have any questions for me with this? So do not forget, this homework is due on next Wednesday, not today. So the only homework due tonight is 7.1. Okay, and yes, 7.1 also have requirement checks here. Because we didn't check any requirements, right? We just plug it into your StatCrunch and whoop, here's your answer here. So so make sure you guys understand that the requirements check for 7.1, which is proportion, simple random sample, binomial, and at least 5 success and at least 5 failures. Those are the requirements check that we have to go through. Okay, but we did some, so make sure you check this before we go on. All right, it's attendance time, so go ahead and put in the chat room attendance here, and we will continue a little bit on 8.1 here. Let's do a question on 7.2. So Anyone have any questions for me here?
So that's the unfortunately we did not fulfill the first
Requirement?
let's see the requirement. Is that the same as the confidence interval is invalid because the data
Yes.
is not okay?
Yes, that is correct. You are
And
correct.
we were supposed to do that for number 1, 2, 3.
For 2 and 3, yep. One is finding critical value. So again, that is only finding confidence interval. You have to check the requirement. Mhm. So we didn't check all these requirements yet. That's why a lot of students just watch out for it. So what is difference between chapter 7 and chapter 8 is chapter 7 is doing what we call as confidence interval. Chapter 8 is doing a hypothesis testing. So you can tell that when you have an option here, the option is either perform hypothesis testing or perform confidence interval. It all depends on the questions. Chapter 7 is mostly asking for confidence interval. Chapter 8 is asking for hypothesis testing. So, so what we do so far is all confidence interval. So now we're going to do hypothesis testing. So what is a hypothesis testing? A hypothesis testing is where we want to test a claim statement. And this claim statement is from the population. So usually when I want you to do hypothesis testing, you should have what we call as a hypothesis. And this hypothesis comes from a statement that talk about population. So we don't talk about sample. For example, the claim statements can be students who got A in my class is greater than 20%. That means more than 20% of this class will get A. And when for not this class, for this stats class. So when I say for this stats class, I'm not talking about your class. I'm talking about in general, in a population, in everyone. So everyone that you take from the claim statement says that you will 20% of you guys will get an A. So again, when I say you guys, I'm talking about everyone who take this class. Okay, it can be last year, this year, last semester. So that is the claim, and it's always based on the population. Same thing happens when you guys write your confidence interval here. You always base it on the population case here, right? So same thing happens here. It's all based on the population. And when we perform a hypothesis testing, this is a procedure. Actually, this is a 6 steps procedure. Yes, we have to go through all 6 steps of this. So this is actually kind of tired with my PDF here. I don't know what happens. It's like, just doesn't know why sometimes. Technologies is so so when you perform this hypothesis testing, you actually have to perform 6 steps procedures. So you have to do 6 steps here. Oh my God, please. So I like to teach in class. I hate to teach using Zoom. 6 steps. Okay. So in this chapter 8.1, we will go through these 6 steps, 1, 2, 3, 4, 5, 6. And then when you do, so they break it down into this step 1, this is step 2, step 3. But when you guys did in the 8.1, 8.2, and 8.3, you actually have to write all these 6 steps into one. These are all the 6 steps here. That means that you will, if you see this, I will just give you the question and you got to write these 6 steps all by yourself. Okay. So, so that's what happens. Same thing happens. So 8.1, they just break these 6 steps into individual pieces. But then when you come to 8.2 and 8.3 and the rest of chapter 9 and 10, you have to write these 6 steps all in one page or one in one blank spot here. So what is the 6 steps you're talking about? The first step is to check your requirements. Okay, and the requirements are simple random sample, binomial, 5 success, 5 failures for the proportion, simple random sample, and the mean one. The mean one has a normal size. So we'll talk about that. So we'll talk about requirement check when you go to 8.2 and 8.3. That's your first step. Second step is to write the statement. There are 2 hypothesis statements you have to write. One is called a null, and one is called the alternative. Okay. The third procedure is what kind of sampling distribution are we using? We got only 2 choices, Z or T, which we learned today. So majority for the proportion case, we will use the Z case, the Z distribution. Okay. So for proportion, we will use the Z distribution. Okay. For mean, we will use the T distribution. So for the mean, we will use the T distribution. So that's how we figure out proportion and mean. The question will tell you which one it is. And then you have to find the p-value and test statistic. This is obtained from your StatCrunch. So when you put in your StatCrunch, they will split up the test statistic and the p-value. And then you have to look at your alpha. Are you rejecting or fail to reject? If your p-value is less than alpha, we will reject. If your p-value is greater than alpha, we fail to reject. This is what we call as your decision. Okay, so step 5 is your decision. Step 6 is your conclusion. Actually, there are 7 steps. Conclusion. Your conclusion is either one of these. There is sufficient evidence to support the claim. There is not sufficient evidence to support the claim. There is sufficient evidence to warrant rejection of the claim. There is not sufficient evidence to warrant. So there are 4 different types of conclusion, and you will pick one based on your decision and also based on your claim statement. Again, I will teach you how to do this. This is something strict. You will not be worried about. No, that is, oh my God, this is so much. And the last thing is to answer the question. The answer to the question is very easy. It's either yes or no. So there are actually 7 steps procedure here. So not 6, 7, my bad. Change that to 7 steps. So there are 7 steps procedure to write a hypothesis testing. So not 6. So the first step is a requirement check. So this one we will go over in the next section in 8.2 and 8.3. So right now for 8.1, we assume that all the requirements are checked, met. Okay, so we are doing that for just this section. Okay, so we're just going through this section. So that is, but when you go to the next 8.2 and 8.3, we will actually check that. Okay, but so for this section, we will say that they're all met in here. Now, these are the 2 hypothesis statements that we will be writing. This is very important. So that what we call the first hypothesis is called the null hypothesis. It denoted by H0 is where your population parameter is equal to the claim value. Okay, means there is no change, no effects, no difference. So we always use the word equal when you write the null hypothesis. So you can tell that the sign that we use here is equal. The population parameter can be P and it can be mu. Okay, it can be P. If you use P, P is for proportion. Mu in this case is for mean. So, so when you write the null hypothesis, the symbol that we use here can be P, can be mu, depends on what type of parameter we're talking about. So if that is talking about population proportion, we use P. If it's mu, we use population mean. Okay, so mostly 8.2 is using P because it's all talking about proportion. And 8.3 is where we talk about mean. So we will use the symbol mu here. Okay. So the null hypothesis always have the equal sign. The alternative hypothesis, there are 3 types, but your textbook use HA, so I'm going to use HA, is where the parameter is somewhat different from the null hypothesis. So we will use this symbol, either it's less than, greater than, or not equals to. So when you write this as your alternative hypothesis, it is either less than, either greater than, or not equal to. It's all stated in the question. So if you remember when you do your chapter 6 homework, right, I asked for it, right? It must be less than 68 pounds. It has to be greater than this. So it's stated in the question. So make sure you read the question and they will tell you which one is which. Is that less than, is that greater than, and is that not equal to? It's usually came from your claim statement. Okay, usually it comes from the claim statement. So read the question really carefully and then figure out which one is this. Now, if you pick the less than is what we call as a left tilt test. This is what less than. So if the question is, the claim statement says this is less than 30% or less than 50% or less than 80%, then we talk about a left tilt test in this case. What is a left tilt test? So I'm going to draw the picture here. Okay, so a left tilt test will look something like this. This is a left tilt test. So it should be less than. So it will be, your shading is on the left side. This is called a left tilt test. Okay, so this is when you will use less than for your claim statement. If you have a right tilt test, we are using greater than, then your shading is only on the right side. This is called a right tilt test. If you have a two tilt test is where you have not equals to, and your shading or your region here is going to be both sides. So that is the difference between your left, right, and two tilt test. So your right tilt test has to be greater, which is greater than. Your two tilt test has to be not equal to. Okay, the symbol not equals to. I don't have that in my, so it cannot equals to. Okay, so that is two tilt test. Now, when you do your left tilt, right tilt, two tilt test, we have the area that you shade here is called rejection area or rejection region. Okay, so all this region is called rejection region. This is two rejection region. Okay, but they are symmetrical. Forget, they are symmetrical. You have two tilts. Okay, now the value that you see over here is called the critical value. Okay, so this number that to cut off between the rejection and the accepted region, the other side without shading is called accepted region. This is called a critical value. And if you got two tilt tests, your critical value is the same. The only difference here is one is plus, one is minus. That is the two tilt test. We did this before in the beginning of the class. Remember, in the beginning of class, in question 1 here, I asked you to find the critical value. So this 2.306, 1.96, these are what we call as your critical value. And it is the purple one that we just mentioned. Okay. And then we got one called test statistic. What is test statistic? A test statistic is a value that where it belongs to this area in this x-axis. If your test statistic fall inside this rejected area, then you have to reject your null hypothesis. However, if your test statistic falls inside this area, which is called the accepted region, then we will fail to reject your null hypothesis. So this is how you figure out hypothesis statement, how you test a hypothesis is based on rejection region, based on critical value, based on test statistic, where does it goes? Is it fall in or outside the shading area? And they also based on p-value. Oh, this is all big words that you have. So in this class, we do not do the rejection area. We don't do the critical value. Okay, so we don't do this. We will do p-value. I will explain to you what is p-value is. So so in this class we will be doing p-value. So we have quite a lot of ways to do perform a hypothesis testing. If you read here, there are 3 methods to perform a hypothesis testing. One is using the p-value method. One is using critical value methods, and one is using the confidence interval methods. So my class, we only concentrate on the p-value methods. So we don't use the critical value or the confidence interval method. But what happens when you say when you have questions in your homework and you say how to solve this? Some of you use that a lot, right? In your homework. If you do how to solve this in your online homework, they will teach you the critical value method. Okay, so again, the reason why I want to point this one out is because if you try to do your homework and you say help me to solve this, or how to solve this, help me here, they will use different methods as this class. So the method they will show you is called critical value method. It is a very long method. If you think 7 steps is long, I think critical value method is like a 10 steps method, even longer. Okay, so I will use the p-value methods, but no matter which method you use, the decision and the conclusion should be the same. Okay, so I'm going to stop here and I will continue this on Monday. So my suggestion to you guys is finish 7.1 homework. Start 7.2 homework and then start reading chapter 8, because chapter 8 materials is really tough because there's a lot of readings. I would recommend you guys to read 8.1. So this weekend, take out your textbook or go to the ebook and read 8.1 sections. Okay, I'm going to stop sharing here. Does anyone have any